target of the software being developed. But if it is not secure, then we are not good to go. So that's why we are saying cybersecurity is a fundamental pillar in the disciplines of ICT. Like everyone has to be equipped with some good knowledge of cybersecurity, from software development to cloud architecture. You realize Uganda and the whole world has embraced cloud. So even when we are on the journey to cloud, we need to be as secure as possible and actually deploy more of our cyber security knowledge to the cloud architecture, because that's where the world is moving to. Then we go ahead to break down cybersecurity into a defense in depth. By defense in depth, we mean implementing overlapping security controls across every layer of the technology stack. By this, what did we mean? We meant that we create overlapping security controls. Like, for instance, you create a system that is secure, but that is not enough. You go down to create a multi-factor authentication to access this particular system, which you've already made that is secure. So we create these overlapping security controls across all the layers. Every single layer of it, please put a secure. Please try to make sure that you create these overlapping security controls on every layer of it. Please, next slide. For our next slide. Yeah. Understanding cybersecurity. So from what I just explained from the first slide, where exactly do we, because I've been talking about cybersecurity and how we need it and how important it is. So we go down to break it down. For instance, in a company, we have endpoints. By endpoints, I mean computers, workstations, laptops, so all those things. So those are the endpoints. And the protection focus for each endpoint, we are looking at the device, which is probably a laptop or a desktop, and user systems. We are sure on most of those laptops, these people access systems. So our protection focus on every single point is one, the device itself and the systems or applications this person is trying to access. And what exactly do we put in place? One, if it's a device, the antivirus has to be updated. It has to be one installed, then updated, and then we have to always run the scans. Two, we put the firewall. Make sure there's a firewall on your network or actually on the laptop itself. Ensure there is always the EDR tools. By the EDR tools, what do I mean? The EDR tools are basically the endpoint detection and response. What are these ones? These EDR tools are basically cybersecurity solutions that monitor endpoint activities. Like you keep monitoring, because if you don't monitor the activities that are happening on your endpoints, they can actually attack you. You have to always monitor. So detect suspicious behavior and help security teams investigate and respond to threat in real time. So on every single device, please deploy these. They will help you to detect early and you're able to do better investigations, because at least you have an understanding of what is happening to your endpoints. Because if you don't deploy these things from a level of endpoints, remember, endpoints are the ones that actually extend this threat to the server environment. So we deploy this particular, the antivirus, the firewall, and the EDR tools. So we go down to break it down to networks. So from a network level or point of view, what are our protection focus? We protect data transmission, because that's what is happening on the network. So what are the key components to look out for? The IP, the IPS, the firewall, and the segmentations. Ensure there's a firewall. Secondly, ensure the network is properly segmented. You realize most companies, they want to save and they end up deploying flat networks. I don't know if you people understand, most of the students understand flat networks, where you create the servers, the endpoints, the network equipment, everything is on the same network. Just in case you're hit by an attacker or he's able to gain access to your network, he can actually see everything. He can actually access everything. From your computer, you can access the servers. From your computer, you can access the switch. You can access the router. So this is wrong. Segment, if you have visitors within the organization, please segment. You need to have the different network access to the guests, and then to the sensitive environment, which are now the servers, and then probably to laptops. Everything has to be segmented. So that's the only way we will secure your network. So we go down to applications. So when we are checking, no, please first go back to the next slide. Yes, that one. The applications. By applications, what did we mean? When probably an insurance company is having the core business application, we look out for the software vulnerabilities in the application that they created for us to use. So, and what are the key components? Secure coding, code reviews, and then the testing. Let me try to be fast. Then, since we are embracing a lot of the cloud infrastructure, so we also broke it down, cloud infrastructure. Under cloud infrastructure, what's the protection focus? The remote data storage. Then the key components here is access control, encryption, and monitoring. You realize if you don't manage access control, who is accessing what, where, when, and how? Then encryption, please try as much as you can to deploy the encryption tools, because you realize this data can be intercepted. And then you monitor. I've already talked about the endpoint detection and response. So you monitor. There's identity management. That is, what are the protection focus? We focus on the user authentication. Please, for as long as the users can access anything without them being authenticated to access, there's already a problem. So what are we actually looking out for? We look out, what are the key components? These are the multi-factor authentication, the access management, and credential protection. Please deploy tools to protect the credentials. Let's proceed to the next slide. After we've discussed what exactly is cybersecurity, from the other slides, we're only talking about what cybersecurity is and what are the particular things or under ICT or to look out for when you're deploying cybersecurity, because we talked about it has a practice, has processes, has technologies. So up there, those are the things we're talking about. Now, here we are talking about why cybersecurity matters today, because from all we thought of cybersecurity. Now I want to interest you. Why are we actually so much into cybersecurity? Why are we bringing this awareness, and why should we be very interested in this topic? Because there's quite a lot. But why are we picking a lot of interest, and why do we take all this time to discuss the disciplines of cybersecurity? So Ephraim, please, you can take it on from here.
Thank you very much, Maureen. That was very insightful. I don't know, does anyone have anything I'd like to add on, a question or insight? You can always feel free to raise your hand and add on any insights you might have. Okay, all right. So why cybersecurity matters? When it's really talked about, it's important to know that cybersecurity it's now part of us. I think it should be part of our daily lives. I'll try to give an example. There, like for instance, where I work, in one of the countries in India, is one of its core businesses is packaging and selling lubricants. So last year they had um, a disastrous attack, which wiped out a lot of the information they had from we're talking about customer information from their ERPs, and it took them nearly, I think, probably over 2 weeks to really get back to a point where they could operate. But in the meantime, you could see that they lost customer orders, possible customer orders. It affected their image, their public image. It affected customers' confidence in them, and the amount of money they lost, I think, was equivalent to roughly, if I recall, about 15 million US dollars, and that was just on a monetary aspect. We're not yet even looking at what the impact might be in as far as lost business in terms of future customers. Okay. All right. So, and another reason is one, technology is growing and rapidly expanding. And not only that, even the bad actors are taking advantage of this, and the tools that they use are getting more and more sophisticated, and they're targeting different people. And the impact of a successful attack is reaching in the trillions when you look at it from all the businesses globally, from some sort of fraud or cybersecurity related incident. You're talking about a lot of money that is lost or could be at risk because of this. And they don't use unknown ways. Some of the common ways in which they attack these companies, the vectors in this case here, you will see phishing emails, especially, they kind of trick you into revealing sensitive information. Then you'll have ransomware. I remember in the UK, their health services system suffered a ransomware attack where they encrypted all their patients' information, patient information, and that was a disaster of its own. Or social engineering, exploiting us and our vulnerabilities, manipulating us into revealing sensitive information. And sometimes also it's identity based. It's the most common form of network intrusions. You'll find like man in the middle attacks or some sort of supply chain attack. And yeah, but please do ask questions if you want to ask. I know for many of you this might be interesting, and if you do want to ask, do go ahead and ask. But also there is a certain level of responsibility that we should all play, and that is critical. For instance, when you neglect some of these threats or try to ignore them, you end up compromising everybody else that would work them, that would rely on your expertise. When you talk about in schools or in your own homes, you expose your loved ones, you expose your own personal information. It's even more, the impact is quite quite higher if it's with businesses. For instance, if you're a developer, if you don't follow some of the best in practice principles, like incorporating security into your development process, exposing your API keys or any other critical information, you end up having a very insecure code base which can be taken advantage of. Network engineers, if you fail to implement proper segmentation within your network, you definitely expose the users within your company to risks, and that is a problem. So as a professional, you have to understand the risks that you face and how to mitigate them. And there are very many ways. There's a lot of information out there in terms of frameworks or best practices and how that you can use or take advantage of to secure your businesses, but also more importantly, your personal lives, your family, for that matter. Now, as professionals, there are very many frameworks. I don't know. I don't know if anybody else also would like to, if you've worked with any of the frameworks, but there are very many systematic frameworks and tools. Like one common one is the NIST framework, which is used to identify, protect, and respond to, and also, if it's to the extent, recover from a number of the cyber incidents. So the NIST framework, it's a simple, like it says it's just a simple framework that organizations can adopt, and it helps organizations structure themselves and put them in a better posture, be able to identify threats, to respond to them, but also manage the businesses or the organizations with respect to how the external environment presents itself. So another one of the categories is, for instance, network administrators. So they can look at their infrastructure and deploy some of the best tools, the most sophisticated tools within the industry to protect their networks. And you're talking about firewalls, you're talking about intrusion prevention systems that detect and block malicious traffic. Then as a developer, you're talking about secure coding practices, for instance, that prevents vulnerabilities like SQL injection. You find, for instance, as a developer, when you have input fields, you may need to perform sanitization on some of these input fields so that you can make sure people don't pass queries through your input fields that corrupt your database and the like. So this is a very important thing. It's one of the oldest, but surprisingly still very common attack vector. Then security specialists. For instance, when you talk about identity management, implementing systems that protect organizations against identity-based attacks. Maureen talked about multi-factor authentication, which is a very important key. You interact with them, I think, through Google Authenticator or Microsoft Authenticator. So there are quite a number of tools that are available that you can take advantage of as well. Then when it comes to what you do at school and how it applies to the industry, for instance, you could study simple topics like network or IP addressing, and why this is a very important topic in cybersecurity is, for instance, in the topic of segmentation, uh, uh, firewall policy, VPN design, securing your routing, even monitoring. This is very, very, very important. Okay. So for instance, in segmentation, you could segment your network in a way that you know traffic that's coming from specific VPNs are supposed to be routed in a certain way, and you can segment it in that way, and that ensures that only that traffic is routed in the way that it's supposed to be routed. You could define specific firewall policies that ensure that only the traffic that is supposed to get out of the network gets out, and the ones that are supposed to get in gets into the network. Then what you study with operating systems, patching, privilege, or even endpoint detection. So, for instance, you have one of your most common operating systems, Linux, most of the Linux-based systems, even Microsoft, generally all of them, they always release incremental updates on a regular basis that always ensure that your operating system is secure and up to date. We've talked about programming, now we talk about database systems or data structures. So this tends to show up in access control, encryption, backups, audit trails, etc. Then we have cloud or system design. There's quite a lot, There's quite a lot that you can do. So there is so much, really. I don't know. Anyone that wants to add on anything? Right?
Yes, that's Maureen. Please go back to that slide.
Okay.
Thank you. About network IP addressing, let me just talk about the VPN design. Let me just elaborate more on them. When it comes to cybersecurity, why do we have to design the VPNs? You realize that there are some people that are going to work from outside the network, and they will need to access probably the systems. They will need to access some resources on the network. So why we have to provide a VPN connection, but it has to be also very secure. Some companies or some people want to dodge payment for the tokens. Cisco is a bit cheap, which they provide those tokens, because I've ever worked for a company which didn't want actually to go into the expense of tokens for the VPN, and people were accessing systems. But anyone who has the network logins, if I can share my logins with Ephraim, I can actually use the Ephraim's login credentials on the VPN, and I access the system. So just in case something goes wrong, there is no accountability, because it is going to be my word against Ephraim's word. I use Ephraim's credentials to access the system on probably a compromised network. So there is need also, if you're to use the VPN, ensure it is also very secure, because you realize you don't know the network you're using to access the system. And there's something else I wanted also to talk about. That was about the backups, that is database. How do backups come in when we're talking about cybersecurity? One, when we are doing backups, and probably also I'll talk about the audit trails. Let me start with audit trail anyway. When systems are being designed, this is now for the system developers. Audit trails is basically to monitor who is accessing the system, with which device, at what time, and what exactly did they do in the system. Because we want to keep track, someone might use the system because he has access and is doing actually something wrong, or is trying to compromise quite a lot. So the audit trail, from audit trails, we're in position to pick this particular kind of information. Backups. How do backups come into cybersecurity? However much we have put up all these measures to prevent these attackers from attacking or accessing our systems, our networks, our cloud environment, we put everything up, but you realize at some point they actually get access, because technology keeps evolving on a daily, and also the attackers keep designing better and better ways of accessing. So we back up this data. It is essential for all of us to run backups. If not, actually, let's run backups on a daily and on a quarterly basis. If not, let's try to restore from the backups that we've done. Test the data you're backing up, because on a bad day when these hackers actually get access, you will refer to these backups. And just imagine the backup you have, you're not able to restore from it, the kind of disaster you'll be in. So it is essential, one, and ensure somewhere we talked about the encryption under database. The backups you're doing, they should be encrypted, or the disks where you're putting these backups, they should be encrypted. Because just imagine on a bad day, this person has already deployed, the hack has already deployed his tool on your system or on your servers or anywhere. You're probably backing up your databases, but someone already deployed his injection on it, and then the whatever you're backing up is already messed up. There's a huge possibility you're trying to back up, let me say, on the 19th of June, but then you had backed up on the 1st of June when this injection had not been put on whatever you're trying to back up. So you're going to mess up everything that you backed up in June. But if this disk was encrypted, a lot would be saved. And just also imagine, because there are people that that are actually back up on disks and then they take them to the bank. So in that process, just imagine your disk is not encrypted and then it falls into the wrong hands on your way to the bank. The kind of data that is going to be out there. Just imagine you work in an insurance company, there is data for patients for the hospitals you insure. What are you going to say to the regulator tomorrow when that data is out and in Day on social media? So please pick it from us that there's need when you're looking at databases. Pay more attention to backups, pay more attention to encryption, pay more attention to audit trails of the systems, because they really, really help when disaster falls. Thank you very much. That's what I wanted to add on.
Oh, great. Thank you very much, Maureen. There's somebody else, I think, who had something to share. Please do go ahead.
Yes, sir. Hi, thanks, Ephraim. Thanks. Can you hear me?
Yes.
All right. Thanks, Ephraim. Thanks,
Perfectly.
Maureen. And yeah, so those are good. Those are good pointers. And well, as I introduced myself earlier, for those who have just jumped in, hi Ray, Philip, Banis. So I think the way I can break down much of this is I'm just going to state one thing. Well, cybersecurity in itself is not a career. Let me first point that out for everyone. Cybersecurity is not a career. Cybersecurity is what I can call it's a subject. It's the same way computer science is not a career. Okay, you can't say I'm a computer scientist. You understand? It's something, yes, you studied, but it's not I would call it a career path, but it is a subject that leads you down a certain set of career paths that basically help improve the IT skills that you already have. And some of those skills are the ones that, as you can see here in the slide, Ephraim was breaking down. Like, for example, again, what you studied. Some people studied and are good with networking. Others are good with systems admins. That's the operating systems. Others are web developers. Web developers usually go hand in hand with database management or database administrators, and also, if you look at cloud engineers or cloud practitioners. So these are some of the specific skills you're learning in university: cloud engineers, network engineering, systems admins, software developers. So if you look at how we broke this down from what you studied in the classroom and how cybersecurity applies to what you studied, this is basically like how you look at it. If you're good at networking, how cybersecurity comes in with your networking skills. You look at network segmenting, okay, VLANs, separating different networks and what type of data they have access to. Can someone please mute it? Sandra, can you please mute and okay, thank you. Yes, so again, if you look at the networking area, how are you implementing VLANs to keep your network secure? How are you looking at how do you create firewall policies to basically limit traffic, and who has access to what traffic, and at what network? Then you look at other things like monitoring and uh, covering logs for how traffic is moving across the systems, what triggers are being created, etc., etc. And what that brings us back to is some of the, I would say, functions or frameworks of how cybersecurity works. If you look at cybersecurity from a larger, high level design or a larger perspective, is you're going to find cybersecurity falls in, like, I would categorize them into 6 areas. Governing, that is, you govern um, data, how data is accessed, when it's accessed, who accesses it, and how they disseminate it. Okay. Then you look at identifying, that is, identifying where the threat is, identifying what data is important, what needs to be protected, identifying which networks and which systems need to be protected. Then obviously you apply the protection. Detection is, yeah, you look at has there been a breach? Is there some suspicious activity going on? Then responding and recovery. So response is where you find many, I would say, incident analysts and SOC analysts. These are some of the career paths that now I will break down for you later on as we go along. And finally, recovery is another part of cybersecurity that is important. This now covers your backups. Okay, because once a system has been compromised and then you have detected the compromise, you've mitigated it. After mitigating it, then you need to guide your organization on that system to recover either the data that has been lost, compromised, and bring it back to a proper working environment. So I think what I would say is cybersecurity, I would set it to ask certain questions like what can go wrong? Okay. If something goes wrong, what do I do? Okay. How do I detect that something has gone wrong? And then on top of what can go wrong, you also then look at the areas of how do I reduce the risk of something going wrong? Okay. And after you detect the risk, after you reduce the risk, okay, basically it is you look at what can go wrong. That is, you're basically you're in the identifying space. Okay. And how do you reduce the risk as well? That comes into also identifying. Then you say, what happens when something has gone wrong? How do I respond? That now comes detection and response. And after that, you say, what evidence do I have to prove that I've made everything okay? And the system is now secure. So that includes now governing and auditing and documentation. So I have to be very honest with you, cybersecurity is a lot of documentation. You have to basically get used to writing reports. I know you're leaving university and all, but with
Yeah.
cybersecurity, you will have to get used to writing reports, interpreting the data
Mm.
into something that you can share to your management and your stakeholders so that they understand what the risk is, how you mitigated it, and how it will not happen again. So, yeah, let me just let Ephraim go on from there, and we'll keep pitching in along the way.
Yeah,
Thank you.
I know when you say it's but thank you. I hope you can hear me. Like, thank you, man. That's true. Cybersecurity definitely does involve a lot of documentation. And incidentally, it's actually true that nearly every IT profession, documentation is heavy, more than people tend to realize. Yeah, but that's actually true. So at the end of the day, it comes down to the next question: who is responsible for cybersecurity? One of the things that I personally have to deal with, uh, especially at work, is trying to let people know that it's their role, it's everyone's role. It doesn't matter if if you're technical or not in the area of cybersecurity or networking or an IT professional, it's everyone's role. We all have a responsibility to make sure that that we are safe in our work environments. So I think I like the statement. One, you don't have to start as a hacker. Security maturity needs builders, operators, analysts, auditors, and communicators. I actually think the hacker mindset might be one of the biggest hindrances. You know, when you see someone run a sudo apt install command in a movie, and then it's giving all these verbal stacks coming down, then you think, wow, that's really cool. Then when you go to do the job, you think you have the mindset that's exciting, but then you realize, oh, there's a lot of investigation, there's a lot of reading, there's a lot of follow-up. You also need to communicate. And some of the interesting things like actually analyzing a threat becomes very, very, very tedious at some point. So that's where we need to really be careful. But at the end of the day, from the security aspect, there's a lot of prevention. So you have to design controls very, very, very early. So some of the controls would be like yes, but
Okay, hold on. I wanted to actually come in and interject on that as well, and and add an interesting feature or an interesting aspect that
yes,
many
go ahead.
university students and some interns I've worked with have asked, and I've had to break it down for them in the simplest of terms, like this: those hackers that you see in the movies, the key aspect about hacking is more or less what I would call, um, uh, in the simplest of terms, hacking is improvising. Most of them improvise. They are guys who just, that's why it's called hacking. They just, you're hitting steps. The one thing you need to understand before you even get into hacking is you have to understand the system, how it works, where the data is going, so that you can do that hacking. And that is the part of cybersecurity most people find boring. Sadly, planning the system. So they usually want to jump.
Exactly.
They usually want to jump into hacking before they learn the system, but you can't do that. You can't. Yeah,
Exactly.
just
Exactly.
also to that.
Okay, fun question. If you've watched a movie, which movie is the most realistic as possible to hacking or real life cybersecurity, in your opinion, if you have any?
Honestly, in my
iRobot.
opinion,
I've
I
seen
would say
iRobot.
Mr.
Uh-huh.
Robot. Actually,
You'd
it's
say
Mr. Robot
Mr.
that is
Mr.
most
Robot.
accurate.
Yes. Yeah.
Yes,
Yeah,
it's
I
most
agree.
accurate. Very, very accurate.
Exactly.
Because it
How
shows
many
you
people?
exactly what
Mm-hmm.
you learned, how
Mm-hmm.
how many people it takes to actually do
Mm-hmm.
a hack. It's not one guy, it's usually a team. And you
It's not
find
one
each of
guy.
those people are
Ex-
doing different aspects of
Uh-huh.
what we have broken down here. There's a
Uh-huh.
database guy, there's a cloud
Uh-huh.
guy, there's a developer guy,
Uh-huh.
there's a networking guy.
Uh-huh.
You get? So
Uh-huh.
you you have to understand all of this. So all of these aspects come together to make cybersecurity. That's why I started with
Uh-huh.
cybersecurity is not a role. Just like that's like you have computer
Oh,
science.
you
You cannot say I'm a computer scientist.
you missed the
No,
social engineer.
you studied computer.
Mm.
Yeah, even social engineers, all those are part of, all those fall under the aspects of cybersecurity. These are
Yeah.
guys who identify, they identify
Mm.
loopholes. So the aspect I was trying to bring
Yeah.
out is what you know, okay? Hone the skill that you know or what you studied, understand it to the point that
Mm.
you're like, okay, how can I break this?
Mm.
If someone breaks this, how can I bring it back together?
Mm.
And how can I prevent someone else from breaking what I
Mm.
know? That
Mm.
is how cybersecurity comes into what basically it's supposed to come in and assist your already existing IT skills so that you look at them from a point of view of
Mm.
one, how do I secure the data? Make sure it is one confidential. 2, accessible, and then also 3, accessible to the right people at the right time, and it is not corrupted. That's CIA triad: confidentiality, integrity, and access.
Oh.
So when you look at what you're doing right now in computer science, in IT, in forensics, etc., you have to focus on those 3. What do I have to protect? Who has to access it? When can they access it? And if something goes wrong, how do I put it back together? Yeah.
Yeah, I couldn't have said it any better. And that actually kind of like talks about what this slide is trying to communicate. So, and what about pathways? Do you talk about the pathways much as people have to hone the current skills they have? Could you throw more light on some of the pathways that people would follow in this regard?
Yeah. Yes. Okay. Some of the pathways I would go at some of the pathways I would look at involve like what line of what skills do you want to hone as far as cybersecurity is concerned. So I know we didn't add much of this into the slides here, but if I was to break down the actual career paths in cybersecurity, we have what they call GRC. That's governance, risk, and compliance. So these are the guys who basically look at, they do a lot of writing policies. They look at the risks, what type of data is at risk, how can we protect it, what policies can we put in place. I like to call this jokingly in the industry, they are called paper pushers because they do write a lot of papers, incidentally, but that is GRC. The other aspect, the other security or career path, I would say, is you have security analysts, and SOC analysts as well. This is also another mature. So GRC and security analysts are more or less on a higher career path. These are mature people who have, studied systems and know how to notice or read alerts, logs, and know that something is wrong. This is suspicious. Let's look into this and study it. Then you have the incident handlers. These are the guys who are basically flagging false positives, actual threats. This is real, this is not real, this is just a system glitch, this is not a hack. And another disclaimer you're going to meet in cybersecurity field, you're going to meet a lot of false positives.
Yeah.
Many, a million, I would even say. But over time, you learn to identify, okay, this is nothing, this is something, because you don't want to be the boy that cried wolf all the time. Otherwise, people won't take you seriously.
Exactly.
So this is where incident handling and security analysts go hand in hand. So the incident handler sends it to the security analyst. The analyst says, this is nothing wrong. So security analysts, incident handling, those fall under the detect, and I would call it I would say the detection and responding phase. Okay, these are the security analysts, incident handlers. Those are detect and respond. Then you have a certain area. I would call it security engineer and cloud. I say cloud security engineers and normal security engineers. Normal security engineers cover network security, things like I would call it network security, identity access and management, backups, permissions. So security engineer, cloud engineers, and cloud security engineers, all I would put them under the protect aspect. So remember, I told you there's govern, identify, protect, detect, respond, and recover. So the security engineers usually fall under mostly protect and recover. Okay, these are the guys that they design the security systems, security measures for the system that you're protecting, whether it's cloud or an organization. So those are the security engineers and the cloud security engineers. Then once they've designed it, they hand it over to the incident handlers, the security analysts. These are the guys that will detect and respond. Okay.
Yeah.
And after that, lastly, we look at the GRC people, like I explained. These are the guys that do the governing. So they will write reports.
Yeah.
They will
Yeah.
send policies and show organizations, okay, this is what happened. This is the risk you face, and this is how you can mitigate that risk as you go along. So the part that most people like and love a lot is the offensive security, is the pen testing. These are the guys that do identify, but identify, like I said, is usually at the upper end of the career path. For you to be able to
Yes.
identify this is a risk, you need to know how it is a risk. You need to know this system is designed like this, and this is where the loophole is. So I would call it a gradual growth. Start from, I would say, learn how to be a security engineer, learn how to implement or how to put certain security aspects in place. After you put them in place, learn how to use them on a day-to-day basis. This is the incident handling. Then learn how to understand or read an incident, a log, and detect that something has gone wrong. So here you're an analyst. And once you're an analyst, you're going to have to write a report. So you come from analyst, you're going to jump into governing, risk analysis, just now GRC. At the end of it all, really, at the top is where you become now the person that is hired to break a system. Those are the offensive security professionals and the pen testers. And I can assure you, because I have actually done a couple of pen testing roles, it is not as easy as it looks in the movies. It is actually, it can take you 6 months, by the way, to do a project for a pen test. Why? Like I said, you're going to have to learn the system.
Yes.
Look at it, know how they work, where the data flow, how does data flow, then you know, okay, this is how I can break in. So as for the practical part, that's like this slide says, learn how to build your own labs internally. I would say for cybersecurity as a must, please learn Linux. If you don't like Linux, start now. At least you have a lot of time. Start. Build your own lab, just install Linux on VM or on your PC, learn how to use Linux, because Linux is open source and it basically allows you to do more with the system than Windows does. And practice.
Yeah.
Now there are a couple of platforms there that we added there. The Try Hack Me. There are some free ones that along the
Yes.
way
Yes.
we shall share, because we couldn't put all of this in one slide, but along the way we shall share that can help you, practice with your home labs. Because I don't want to tell you jump into certifications, because certifications help you get inside the door, but it's your practice that keeps you in that room. Otherwise, you get in the door and they'll throw you out through the window. Yeah, I read an interesting email. Okay, it was a screenshot of an email of a guy who recommended his colleague to an organization. And after he made the recommendation, the organization came back and said, but boss, the guy you recommended to us couldn't even solve the simplest thing. So we're going to look into you as well, because it looks like you don't know what we wanted.
But
And now
exactly.
we're worried about, Yeah, so we're also going to look into you and reevaluate your credentials. You get, it's a tough job,
Yeah.
obviously, but
I
you
remember that.
see,
I think I've seen
if
that.
you just do
Yeah.
if
Oh,
we just do
that's
certifications,
yes.
you're just going
You
to take it to
definitely.
the room, but you need to
Yeah.
practice, practice, so that you can
Practice.
stay in that room. And this is where these home labs come in, and most of them comfortably are Linux based. So I guess along the way with Gideon's and Ephraim and the Secretariat, we shall share some tools that are open source that don't require to pay a lot of money, that you can start with. But along the way, you have to also invest in yourself. Get us $100, open a Try Hack Me account, join the Hack the Box Academy. I think Hack the Box is actually being closed, but anyway, they are transitioning to something else. But pay the $100, try out this platform and it doesn't take you more than 3 months. By the way, if you practice within 3 months, you'll be able to have ascertained some good level of practical skills that you can implement. And lastly, there I have to also add, there's that part 3 that Ephraim also laughed about, but in every, okay, like in my case, at the end of the pen testing project, let me tell you guys, I spent a month documenting, writing a report, screenshots. That is the part that honestly, I will not lie, people will say it sucks, but it is the most important in cybersecurity because no one cares what you can do if you cannot break it down for them to understand. Yeah, I don't want to add too much, so Ephraim, over to you again.
Okay. All right. I think in short, what you really have talked about is really the organization into strategy, governance, and execution and technical. And with that note, we have 2 interesting questions from, I think, Joel. The first one is, are security engineers necessarily, do they necessarily need to be system or software developers? A quick answer.
Not necessarily. Security engineers, okay, I would say security engineers would be systems admins. Most security engineers are systems admins and network engineers. They come from the aspect of because they've set up systems. By systems, I mean they've built networks, they've built server environments like virtual machines, also probably databases, etc. And now they know how to protect these systems so that people can access them securely, can access them when they need them, and also prevent and people who don't need or who are not required to access them to access them. So most security engineers, the reason I love to talk with cloud security is because in the cloud you're building an environment. So the only thing, basically, a cloud engineer is a systems engineer, systems admin, just that because it's called cloud, but as I'm sure by now you all know, the cloud is just someone's computer somewhere else.
Somewhere else.
Your
It's
laptop
another
can
physical.
actually be called.
Exactly.
Yeah, your laptop can be a cloud environment as long as it's accessed. So the only difference is it's accessed remotely. So cloud engineers, security engineers are usually they go hand in hand. Software developers do come in and help when it comes to application and API security. So I think I think software developers and the software engineers are very good application security and API security people. That's how best I can answer that.
Okay, great. I think also George provided a very good answer as well. Yeah. Do you want to elaborate on it? Is he on the call? Okay. But there is another question, just in case. How do you define a time scope for a pen test activity for an organization? He has heard that it takes some good time, could be 6 months. So how do I, that's him, after defining the testing boundaries, then define the time scope? Joel Kidima from Kumba University. Thank you, Joel, for your question. Those are very good questions. Yes. Anybody who can give this a quick shot?
Okay, thank you, Joel, for that as well. Well, from my experience, yeah, it's a good question because one, there is no specified time limit for a pen test. The only thing that usually specifies that is the size of the environment you're dealing with and what are the targets or what are the goals of the pen test. So usually before a penetration test, there's what they call a vulnerability assessment. When you do a vulnerability assessment, you look at what is in place. Do they have a firewall? Do they have endpoint security? Basically, the things that Maureen talked about earlier.
Yes.
Do they have endpoint security? That is antivirus, endpoint detection and response. Do they have firewalls? Do they have firewall policies? What kind of policies do they have? Do they have identity access and management? By the way, identity access and management is the fancy word for what old school was Active Directory. But yeah, for those who remember and are saying that, but that is also still under systems admin. So do they have those measures and those policies in place? So once you have that vulnerability assessment, you give it to the customer. Once you give it to the customer, you ask them, what is the scope of this test? Why? Some tests are one, some penetration tests are for, I would call them applications. The client also test, can our applications be compromised? Can our APIs be compromised? So you try to compromise those. Then you give a time frame for that. Other pen tests are just network based. Can our network be attacked from the outside? Can they get in? When they get in, how do they get in? Which ports are open? What do we need to close? etc. That also has a different scope. Then other penetration tests or scopes is our identity, access management, secure, like zero trust, like what Maureen also said, is what they call zero trust architecture, whereby you create a system that doesn't trust anyone. Whoever is getting in has to identify themselves from scratch. Whether you just got in a few minutes ago, it doesn't care. Zero trust, and from whether your machine is known, So that is also a different scope. So the scope of the penetration test is what determines the time. Then there are those which encompass the entire organization. Those usually take longer, even a year or more, because after you do the pen test, then you have to write a report, then you have to also write mitigation, and then you share with them, with the organization. So the time period for the pen test depends on the scope. That is why there are different penetration testing, I'd call them certifications. There are some for applications, there are some for systems, and there are some for actually just wireless. Yeah, wireless pen tests, because that scope is what determines what time, and also determines on what you focus on. Because sometimes you can't focus on the whole system at once alone. You usually need a team of people, and you break it down over time like that. So the scope of the pen test determines the time, and the time and scope are also determined by your vulnerability assessment. What you find is lacking, they have to first fix. After they fix, you start your test. You get, yeah.
Perfect. Great. So I guess this is very critical. We won't really get into this. This is important. Now, just for time, I'd like to really just talk about why, for instance, how cybersecurity fits within the context of Uganda, and why, especially the group of people in this audience here, particularly important. Well, we know that Uganda is experiencing rapid, I would say actually quite rapid, its digital transformation across various sectors. We're talking of health, finance, government, and the digital economy is growing. And it's important, therefore, that we protect this infrastructure because many people are continuously relying on it. You're talking of fintechs, you're talking of the farmers who are probably relying on some of the applications that students themselves are developing. And the systems that you develop definitely need to be protected in some. But you see, this presents some unique challenges because it's a growing field. There may not be very many experts in this field. Okay. And because we are continuously digitizing a number of things that we're doing, the threat landscape is vastly increasing, not only because of that, but also because technology is changing. It changes rapidly. Things become outdated very quickly. And at the same time, we're playing catch up with most of the with compliance and also some of the global standards that are established, like trying to play catch up with Europe, with UK, with the US, etc. So students, I think, have a unique opportunity to build and secure the foundation to ensure this and sustain economic growth, so you can pursue the various paths that have been presented and shared today. But at the same time, the vision is also there. Uh, as a country, we want to protect the national infrastructure, support business transformation, and position Uganda as an East African hub. And I'm not sure there've been quite a bit of questions, but as far as as far as Maureen Barnes and myself are concerned, we, for our part, I think NCR would, I think, like to get into the various questions that people have asked. So there are those in the chat, but I think it's okay for people to unmute and ask questions.
Emily, I don't know if you are the one with the primary right to unmuting, or if the people that have questions actually have the right to unmute on their own. If you'd like to ask questions, please go ahead and just raise your hand and you'll be able to go ahead and ask. Or if not, maybe Ephraim, we could go ahead and start with the ones in the chat. All the people that sent the messages in the chat, please, you could go ahead and unmute and ask the questions directly. Thank you.
Okay, I'm going to start with Mr. Hilarious. Are there entry jobs for cybersecurity? Most of the ads he sees require 3+ years of experience. Maureen, Panis?
Okay, just want to briefly speak on that. The truth of the matter is, I would say no. And the reason is because, yes, the market is looking for cybersecurity people. So you'll find, first of all, there's lack of awareness in the market so far about cybersecurity and what it covers. But like I explained earlier in my opening, cybersecurity is basically start from what you already know, and you just add a security question to that. For example, are you good at networking? How do I secure my network? Are you good at, are you a software developer? Okay, how do I make sure my API cannot be abused? And, are you a cloud person? Are you a systems admin? So I would say the entry roles are, what are you good at? Are you good at networking? Start as a network engineer. Then, from network engineer, see how you can apply cybersecurity to your network. If you're an app software developer, like someone asked about security engineer and software development. If you're a software developer, start as a developer. Then look at how can I secure my application? Where's my application seated? How do they create infrastructure? It's in the cloud. Okay. How do they secure it in the cloud? It's basically what you already know or what you're good at, and then you apply the security questions to them. That then makes you cybersecurity professional. So that's where those something 2-3+ years coming. So you get in with what you know, apply the questions yourself, secure your environments, and that's how you get the experience. Yeah, that's my input.
I also think that, in my personal opinion, I don't think cybersecurity should be an entry-level role, specifically because you require, I think, understanding from various aspects, from various fields. So we can go to the next question. I think Senyendo Ian, he says,
Ephraim,
yes,
before actually we go into that,
yes,
I have
please.
an add-on to that.
Go ahead, go
It
ahead.
shouldn't be an entry level. Why? This person has to first understand what he's protecting.
Mm,
If it's a systems administrator, he has to first understand systems, networking. Like there's quite a lot to first understand because you cannot start, what's the right word? You cannot catch a thief until you know what you're protecting. You need to know what is in the house, what is there to be protected, how should this be protected, which kind of protection do we actually need to implement to be able to protect what we are protecting. So until someone, actually me, I would advise, so let them first do their first undergrad, try to work for some time, then they understand better what exactly is going on in this so-called ICT, and then they can actually better protect because now they understand. You understand the network, you understand the server environment, you understand endpoints, you understand cloud architecture, like you understand what you're in a better position to tailor
mm,
the right
yes.
solutions to these particular
Mm.
infrastructures that you're trying to protect. Yes, that's what I had to say. But I see quite a lot of hands.
I've seen two hands. I'll start with the Mr. Nwabine Bonaventure. I've seen your hand up. You can unmute and ask a question.
Thank you so much. Can you hear me?
Yes,
Hello?
we can hear you clearly.
Okay,
We
thank
can
you so
hear you
much.
very clearly.
Thank you so much for the session, to all the panelists. Mine is a bit off topic from the current, so I would just request that we first finish the other questions relating to what has just been said, and then we move into mine. Thank you.
Okay, someone will have to remind me that Mr. Bonaventure has a question he would like to ask. Then I think Hilarious, please, Mr.
Okay,
Hilarious, maybe I'm
thank you.
mistaken, but
I appreciate you for your feedback, but yeah, I understand you people are trying so much to talk about experience with that's 3 years. But here is my issue. Because someone already has my question in the chat. He's talking about if he has experience of try hack me, hack the box. So what if that someone, let's say just maybe has done this undergraduate, hasn't worked yet, we assume, but he has COPTIA, he has ISCO certifications, Google certifications, maybe around 20. You mean to say that person doesn't have enough knowledge for an interest subject to the job? Thank you.
no, in that regard, I don't. Okay, sorry, Bryce, go ahead. Bernice, go ahead. Sorry.
Okay. Let me break it down for you like this. Hilarious. You can do all that practice. You can do hack the box. You can get your CompTIA, Security Plus. You can get your CompTIA Cybersecurity Analyst. Okay, but no one, and I mean this in the most candid ways, no organization really cares. What those certifications show to them is, okay, you are knowledgeable. Yes, you have done the exams, but every organization has a different system. Every organization's system and how they operate and how they work varies, and every sector. For example, cybersecurity in banking is different from cybersecurity in telecom. Okay, this is why you find when they ask for the experience, they want to know, have you worked in a banking environment before, so that you know bank systems, and they'll be confident and say, okay, at least the time it will take for them to teach you their systems will be less, so it will be quicker for you to start working. You have to look at it from the point of view of the employer. When they are employing you, they are looking to answer this question: of what benefit are you to their organization? Not whether you've done, I don't know, How many certifications? I know guys who have actually moved up in cybersecurity roles in organizations, and they have never done a CompTIA certification, not one. But the things the guy can do is because over time he has practiced and he has learned. Now, the hack the box is good. The try hack me, they're good because they teach you real life scenarios. Okay, in the event you don't have a job, and I know the job market is hard, but like we said before, take entry level roles for anything ICT related. Then within there, build your cybersecurity portfolio from there. The reason they want people who are experienced in cybersecurity with X number of years is because they want to know, have you actually interacted with a real live system before they can trust you with theirs? That is the key aspect. So it's not, I'm not saying that don't read, your certifications are useless. No. Like I said, those things get you in the door. What can keep you in the door? Analytical skills keep you in that door. Practice keeps you in that door. Curiosity keeps you in that door. Humility, a lot of it keeps you in that door. And being able to learn keeps you within that door. But if you get in and you assume, but I did this, that I need this amount of pay, etc., you're not going to get anywhere. You won't help yourself. So whether you do that SAT, go for that entry level, go for that systems admin role. Okay, fine, it's an intern role. Go in, get there, work in that system. Now you add it on your CV. It will show you that I've protected the system for this organization before. That is what employers want to know. They don't want to know the theory. They want to know in the real world, is that something you have protected? Okay, and that is why I was saying do the practice. When you do the practice also, like for example, software developers and application developers, usually for most of your job interviews, your potential employers will HR people ask you if you have, let's say, a GitHub account. They want to look at your repository. What have you designed in the past before? You get. They want to know what have you done, so that we know you can actually do this stuff that you say you can do. So even when you do those practice, those hack the box things, you put those on your CV, and then you share the link with them, and you're like, by the way, this is what I've done, and the document. Now, when you document, I created the SIM in Hack the Box, was that SIM, I did this, added these policies, and then you send them that document as with your CV. Believe you me, they will consider you more than someone who says, I did CompTIA Security Plus. Okay, you did it. Then what did you do with it? You get. So those labs, those home labs you create, test them, document, add those documentations to your CV. For the developers, develop, get a GitHub account. It's free, Have though that, because GitHub also helps you create audit trails, which is part of cybersecurity. Give them access to that repository. Let them see what you've done. That is how you get in the door. Yeah, that's my feedback.
Okay, perfect. At this juncture, I'd like to invite Jerry. Jerry, are you online right now?
Yes. Do confirm that you hear me.
Perfectly.
Okay. Good afternoon, everyone. I hope you're enjoying the session as I have been.
Geraldine?
Yes, please.
Ephraim?
Yes.
Geraldine, we want you to switch on your video. Ephraim, can you switch off the screen? Can you stop screen sharing?
Okay, let me try this.
Then want us to use her video. Thank you. Okay.
Okay.
Maybe this can help my team when they're taking a screenshot. Thank you. Welcome.
Okay.
Geraldine.
Okay. Yes. Thank you for that. Introduction. So I'm Geraldine Mugumya. I'm a risk analyst. I work at the National IT Authority, specifically in the Department for Information Security, and our mandate is mainly on coordinating and implementing cybersecurity initiatives within Uganda. So I'm happy and really, really glad for this forum. Taking this initiative because this really feeds into the bigger vision that we have in terms of cybersecurity from NITA. One of the guiding policies that we have is the National Cybersecurity Policy, and one of the pillars in there is to have a cyber-skilled Uganda, because when it comes to cybersecurity, and I loved how the different presenters were talking about cybersecurity, it not being a career. There's so many things in there. It's a whole big, world in there. So many things are happening. Like, you have so many opportunities. So I really want to thank the leadership, for the digital leadership, for this session and initiative, because when it comes to cybersecurity, it's not that now from government we are launching, coming up. Maybe someone can mute the person talking. It's someone who is interrupting. Thank you. So, as I was saying, as NITAU, we are bringing along, introducing new e-services for citizens to ease their, now getting your driving permit can take just 5 minutes. So that's all about digital services. But at the end of the day, we are also creating, I don't want to call it a monster, but we are exposing in terms of, the criminals who want to benefit from the information that is on these services. So this is where now we need experts in cybersecurity to ensure that these services are secure, and so this improves our trust, or shows the trust in our citizens, that if I'm to put there my money, if I'm going to make a payment digitally, I know it's going to reach the right person. No one is going to steal it, because behind the scenes there is a security expert, there is a security engineer who is in making sure that the platform, right from when someone initiates to send money to the until the person receives it and is able to withdraw it, that whole process is secure. So I'm really glad for this initiative, and I also want to encourage all of you. Let it not be this just because you have been on this session. Also take the initiative. There is quite a lot that you can learn around cybersecurity from free resources, YouTube. I know they've talked about so many of the different resources that you can use. I wouldn't want to repeat that, but I am really, really very glad that this has happened. And please continue to engage. If anything, if any other sessions come up, keep your mind engaged, learn. Learning doesn't stop, and this will help you understand the world of cybersecurity. So thank you so much.
Sorry, thank you very much, Jerry. That was very insightful. Thank you for taking the time to speak to us as well, and encouraging words. Gideon, I'd like to hand this over to you, I guess.
Ephraim, also before, or as Gideon is coming on, I just wanted to add something else that is NITA actually, because I've actually participated in some of this. NITA usually has that computer emergency CRT Uganda, computer emergency response team programs usually every year. I think there are two. Are they two or one? I think it's one, but I've participated in most of them. And for most of you guys who really want to get your hands-on skills, I would encourage you to look out for them. I think Gideon will be posting, and NITA actually does post much of this on LinkedIn. See if you can get involved in those CRT programs that NITA does. And those also help you, network with your potential employers along the way. You never know what you'll get when you join those. Yeah, that's something I wanted to add. on the side.
Yeah.
Thank you.
Thank you. Thank you. That's true.
Okay, I think I will close on Gideon's behalf. I don't know if all the questions were answered satisfactory. I don't know if there are any more questions in the chat.
Yeah.
If they
Actually,
aren't,
quite a number.
let me see, what's the time? It's okay. Do we have that time to respond to those questions, or even like 2 questions?
Well,
We should
okay. What
take on at least 2 minutes.
I think if I would say try and write them down, and then maybe we can answer them and send to or post them somewhere. I don't know if there's a platform we can use because some of them are interesting really, but I'm looking at the time and it's a bit tricky
I agree.
to answer them all at once within the time we have. But if there's a way we can write them all down and then share them and we can answer them within our platform and send back out to the community.
Perfect. Claudine and Emily, kindly do take note of the questions so that we are able to give detailed responses to what has been asked. I think they'll also be available in the reports that we'll make available to those that have attended. All right, I will just take this time and just share our sincere gratitude to the presenters. This has been such an insightful call, and I think the module in which the information has been shared was really, really insightful in a way that it was not. I am not an IT expert, but however, I can say I can confidently speak on what we've shared because of the mode of delivery. We appreciate the way you have been able to relay all these fundamentals in such an easy way to digest while maintaining all the technical aspects. We are truly, truly grateful for the preparation that the team, the panelists, were able to put in. Truly, truly, it's evident. I also just want to say thank you to the people that have been able to attend the call, the students that have been able to attend the call. You have really showed up. We will have continuous engagements so that we are able to go deeper into these fundamentals that we intend to explore throughout the tech scaling program. So I just want to say thank you once again. We will be calling upon you once again to join the forums program. Please do make yourself available. And we look forward to working with you. To the panelists, thank you so much once again. It's been an amazing time. Gideon and the Secretariat, we are grateful for you and the forum to allow for such a platform to be able to, have such information shared so practically from an experience point of view, the technical aspects. It's been amazing. Thank you. I can see Ken Gisha saying we did not register. Emily, did the people on the call have a form that they filled?
Yeah, we have a registration form. It's on all our social media pages. Everyone who registered to be part of the Tech Talent Program, we have a registration form. But as well, this report is going to be shared with with their lecturers. They will receive them because we are in touch with you through your universities. Number 2, ask any question on our social media pages. We will ask them to respond to you. Comment on this banner for this and put that question. Our team is going to respond to that question. But mainly, we shared a link on our social media pages for you to register to be part of the Tech Talent Program. They'll receive an email blast.
Oh, okay, perfect. I think if there is nothing else, we will then close the call. Thank you so much to everyone, the panelists. It's been amazing. Thank you so much.
Thank you, Ephraim.
All right, thanks everyone.
Bunnies, thanks for shining, huh? Yeah. And Maureen, you guys have done it. Thank you so much.
Well, thank you guys. It was a pleasure.
You're welcome. Thank you for joining as well.
Geraldine from NITAU, greetings to the NITAU team. Thank you so much for joining on such short notice. Greetings to Julian Reju, our director, and also our AD, Doctor. I think we shall send a brief on what has transpired. Thank you so much. Thank you, everyone. Bye.
Okay. God bless you all.
Yes.